In this session, we will dive into hands-on experience using OpenAI SDK to build agents that interact with the language model and utilize tools to collaborate on simple tasks. We will apply concept from previous Agentic session series. While this session is self-contained and it does not require prerequisites, however, I suggest watching the earlier session for high-level overview of Agentic framework to better understand the context. So now let's start. So first we will build a single agent and we will create a single agent that interacts with the language model using both OpenAI GPT and local OLAMA setup. And then we will extend that agent to use tool and what it means like now our agent will be capable of calling uh, uh, a weather API tool to fetch data. Then we will extend our agent to give a structured output, and we will also use guardrails. And then finally, our code will be a multi-agent collaboration, which collaborates as well as uses multiple tools. Okay, so this is our first single agent, and logically the code can be easily uh, thought of like first it has to read the environment variables, which is basically where it will read the OpenAI keys from environment, and then we will have one function of for example what we are calling it as a get model. So based on which model we want to use, it will return the model. So for example, the code which you can see here, it is basically we have written to return two types of model, either the local OLAMA or GPT. So once we have got the reference to model, all we have to do is create the instance of agent, and to create the instance of an agent, basically we need two main thing. One is the system prompt, which will set the persona for the agent, and then the model reference. So in this example, you can see our agent number one is going to use a local Olama, and agent number two is going to use the GPT. And once we have set instantiated the agents, so in the very next step, we just go and run those agents. So I have written code for both, which can be either used as from the command line, or it can be also used using the Jupyter. So whichever you are comfortable, you can use. So let's run the very first code here and see how it goes. So okay, looks like I have ran this code earlier. So I go and just say clear all cells, and we will restart from the beginning. So here we go. So it has loaded the environment variable, and now we are just going to instantiate our function. And our user prompt is tell a joke about autonomous AI agent. And let's see how it goes here. So now the code runs successfully, and if you can see the result, so the result from Olama is like it gives me a joke here. I said that I was reading about autonomous AI agents the other day, and I realized they are not that different from my personal assistant, Shah. So some type of a joke it is trying to create. And now let's say GPT. So GPT came up with a joke like, why did autonomous agent break up with its human partner? Because it realized it could get updates without emotional baggage. So yeah, I mean, both the models, they came up with a joke. Now let's move on to our second agent, and this agent is going to use external tool. And the one change what we will do in this code is basically they extend the previous code and add a tool which will call this weather API. So in OpenAI SDK, if you want to make a function act like a tool, all we need to do is basically add this function tool annotation, and then this function can be used as a tool. And so remaining code is the same what we have already done. The only change now we have to do is basically pass the tool to our agent, and based on the user prompt, the model decides when to call the tool. So, for example, when we are saying what is the weather in Texas, the model will literally call the tool and pass Texas as the parameter. So basically, it calls the API and it knows which parameter to fill in. So in this case, it will call the API and pass Texas as a place of interest for which the weather API has to return the data. So now let's execute this code and see how it goes. So now we got the output, and it says that result from the weather report, and you can see like weather alerts for Texas, and it does give some type of report and information. Now let's start with our third example, where we will see how to use this structure output and the guardrails. So when we say like this structured output, what we expect, like the output coming out from the model has to follow certain structure, and that is very useful when we are communicating with the model and we want certain uh, decisions. So for example, for this use case, uh, we want the model to decide whether in a sentence uh, do we have any name, and if it finds a name, it should tell that this particular sentence has some type of a name, and if it doesn't, it should say it doesn't have a name. It is as simple as that, but the idea is like we will just conceptually verify how can we get a structured output from model. Then once that is done, then we will also use guardrails. So guardrails are used to basically uh, guard either the input message or the output message coming from the model. So when I say input message, basically guardrail can be used to check the user prompt, like nothing incorrect or inappropriate is being passed to the model. And when we call as a output guardrails, basically we are checking the response which has come from the model does not contain any inappropriate messages or data. So for our case, we will use input guardrail. So now let's see what change we need to do. So from code perspective, all we need to do is now we have to add this line, which is basically says that the output type is equal to name check output. And if you recall, a name check output is the class name where we have defined how the the structure should be formed, and then we also pass the input guardrails. So in this, if you can see, like we are just passing the guardrail. So now let's uh, let's run the code and see how it goes. So we ran the first test. What we have says that user prompt has he stole John Wick's car, and if you see the message, the it does say like is name in message. It says yes, there is a name in message, and the name is a John. So the model was very confidently find the name. Now let's take our next message and let's see how it goes. And that is very much true. Like in the next message you can read here, uh, basically there is no name, and it does say like is name in message. It is a false message, does not contain any names. Now let's start with our fourth example, which is a multi-agent collaborations and tools. And if you scroll down here, what we have done that we have defined one agent as a searcher. It has access to the model, and its responsibility is basically to search web based on user query. And what we have done is like the agent can also act like a tool. So if you see in the previous example, we had a function and we used function tool and annotation to a mark of a function as a tool. But in this case, what we are doing is we are marking a agent itself as a tool so that it can be used with by a separate or a different uh, agent, and that is easily done by this function as tool. And so we have done the same thing for two of our agent. One is the details reporter and one is the search reporter. And the system prompt or the tool description, that is what differentiates between these two agents. Now our user prompt is search the web for a local sports news, give me one interesting update in the sentence. And I am interested in Toronto Raptors, Toronto Blue Jays, and Toronto Maple Leaf. So now let's execute that code and see what we get. So this might take little time because we are asking two of our agents to search the web and then generate different results. One of them will be giving a precise report, and the next one gives us a detailed report. So let's see. So the very first one came with a, a result from the search reporter, and if you have seen here, it does give me most recent news, which is like in a 3-1. And now if we go to the detailed reporter, it does give me a little bit of detail when compared to the first outcome. So with this, we finish our multi-agent collaboration example also. So I have shared the link of this code in video. And if you find this content useful, please subscribe and let me know if we have any uh, comment